Yeah, the recording is now starting. So now we can start. Okay. Wait. Now I will open up the PPT. Okay. The PPT for the lecture 2 have already been uploaded to the Moodle. So you should go to the Moodle and download the corresponding lecture notes. Okay. And last time we actually talked about agent and environment. Okay. So essentially, the core concept here is that we can actually represent anything that sense the environment and react to the environment as an agent. Okay, so whenever it is human beings or AI system, as long as it can sense the environment, pick up the stimuli of the environment, and then act accordingly, then it is called an agent. Okay, so that is why if you take a look on many AI papers, AI news nowadays, okay, the news about AI, okay, or the academic papers about AI, you will see the term agent appearing a lot. Okay, and the definition of agent is actually something like this. Okay, okay, and essentially, when we are talking about agents, okay, the agent is sensing the environment. And then after the environment is being sensed, okay, the agent will try to do actions to respond to the environment, right? So in that sense, you can also try to abstract the concept of an agent as a function, okay? Because in mathematics, function is a mapping between things in a domain to things in another domain. Okay? Okay? So if you recall what you learned in mathematics in secondary school, okay? Function, you can take the definition of function to the extreme, that is mapping things from one domain or one set to things in other set or in other domain. Okay? If we take this definition, then we can consider agent itself as a function. Okay? Okay? We don't care about how the mapping is computed. Okay? But theoretically speaking, according to definition, how agent actually is behaving can be considered as a function. Okay? And the function itself, okay, cannot be operational unless it is being computed or being implemented in real life. Okay? Okay? So I had my mind, okay, is existing in my brain. Okay? If there is no brain, then my mind will also vanish. Okay? Okay? Or I write a piece of software or write a piece of program, but without a CPU to really execute it, then the program is just a bunch of binary codes, okay, or just a bunch of source code, okay. You need to have something to execute those codes or those functions such that it really is doing computation in real world, and we call it as an architecture. Okay, okay. You can consider something like this. I buy a game, okay? The game require me to have a GPU as powerful as 3080, okay? But I only have integrated GPU. So I still cannot play the game even I have the game. Okay? In that situation, then the GPU will become the architecture of that game. Okay? Okay? So any questions? Any questions? So we can also define some terms, okay? The precept is essentially about the sensor sensing the environment. The action is essentially the component that react to the environment. And the environment is essentially talking about what kinds of things is situated around the agent, okay, that the agent should respond to, okay? The agent can sense what element is around it, okay? the agent can also do actions among the things surrounding the agent itself. Okay, and we'll say the things surrounding the agent as the environment. Okay, and also when we are talking about precept environment action, it seems that we already finished the whole story, but there is one part of the story that we also need to consider, and that component is the goal. Okay, okay. I believe that every one of you know that when you are working in a company, okay, you have KPI, right? Okay, you have KPI, and your boss will look at your KPI and see whether you are performing good or bad, right? So when we are working with an agent, when we're deciding an AI agent, or when we are describing an AI agent, we also want to talk about whether the agent is behaving good or behaving bad in the environment. Without a measurement, we cannot establish the fact that whether the agent is performing good or not. So that is why we have the goal. Okay, the goal has to be established so that we can measure whether our agent is doing good or not. Okay. Okay, so these are the four components that we often need to consider when we are designing agent. Okay, and you may think that, Professor, why we need to discuss all these facts? The reasoning is that I need to explain the terminology to every one of you. Okay, let's say you want to be researchers in AI in the future. Okay, then you need to publish academic paper, right? And when you try to publish academic paper, what you want to do is to use the same terminology to explain concepts to other people. Okay, so in that sense, you need to learn what are the terminology you can use to explain a AI work, and you also need to know how to use those terminology. So this is why we have these lecture notes. Okay, okay, and we will introduce an example, try to give you some more solid examples to describe all these concepts, okay? So emergent, we have a simple world, okay? Emergent, we have a simple environment, okay? And in this environment, we have two rooms, okay? The left room is called the A, and the right room is actually called the B, okay? And inside this environment, there is a agent, okay? And the agent is called the webcam cleaner, okay? You can consider webcam cleaner similar to the AI webcam cleaning books that you can buy nowadays, okay? And the vacuum cleaning box is designed to do one thing. It is designed to clean the two rooms in this environment. Okay, so to achieve this objective or to achieve this goal, the agent, okay, or the vacuum cleaner, automatic vacuum cleaner, will have the ability to sense what room it is situated in, and also sense whether the room is dirty or not. Okay, okay, and the agent will try to take the location that it knows where it is, okay, and to check whether the room is dirty or not, and figure out a strategy to clean the rooms. Okay, okay. So this is what the vacuum cleaning well supposed to be doing. Okay. So as a result, okay, the agent will have the following preset or following senses, okay? It can sense two things, okay? The first item it sense is where it's located in, and the second thing it can sense is the dirtiness of the room. And we can combine these two sensing items together as a vector. Okay? Okay? So this is what the preset is shown here supposed to be. Okay? Okay? And after the agent have sensed the two items, that is where the agent is situated in and whether the room is dirty or not, okay, then it can have the following four actions. The agent can move to the left, it can move to the right, and the agent can move to the left. Okay, as you can see here, the first action the agent can do, the agent can move to the right. And the second action the agent can do is move to the left. Okay, so originally the agent is at A. After the right action, it goes to room B. Okay, so for example, in the second example, the agent is located in room B. Okay, and after the left action, it moves to room A. Okay, so these are two actions is actually changing the location of the agent. And then the second action and the third action we show here is the sub action. Okay, the sub action the agent will try to collect the dust from the room and then clean the room. Okay, so this is the third action. Okay, the third action is actually handling whether the room is dirty or not. Okay, okay. And the fourth action is there is no action being done. Okay. So we have defined the environment. The environment is two rooms, and the room can be dirty or not. Okay. And we also define that the agent's preset. The agent can sense which room is located in, and also how dirty the room is. Finally, we also define the action that the agent can do. Okay, there are four actions that the agent can do. Okay, so essentially through the definition process that I have done, I have actually reduced the problem into a bunch of variables and status. Okay, okay. Instead of a long verbal description, I have actually simplified the problem as a bunch of labels. Okay. For example, the environment I just reduce it to two rooms, dirty or not. Okay. So you can use two Boolean variables to represent the environment. Okay. Okay. And for the status of the agent, for the sensor that the agent can perceive, after my modeling, I now reduce it to two variables. The first one is the room that the agent situated in, and the second variable is the room is dirty or not. Okay. And after my simplification, the action of the agent is now reduced to four choices. Okay. 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 So now when we are trying to figure out what kinds of how the agent will interact with the environment, then what we need to discuss is around you can be done using the verbal I just defined. Okay, I don't need to go back to verbal description. I can use all these variables I just defined to describe the problem that I need to solve and to describe how my agent will interact with the environment. Okay? Okay? So in that sense, that is what the try to convert the problem into symbols really means. Okay? I ditch away the verbal description, the text description, and now I am using different variables to describe the different status of the environment. And because I've done so, the problem that I'm working with can now define with those symbols as well. The things that the agent can sense can be described by those variables as well. And the action of the agent can be described by those variables as well. Okay. And after this transformation, now we are working with variables. We are working with some numbers, some Boolean variables, and some vectors. Those are the things computers know how to solve very, very easily. Okay. Okay. So that is the reason why in the early development of the AI, we use symbolism AI. After we convert the problem from text into variables, then all the things can be easily programmable in a computer. Okay? Okay? And this is so-called the agent function, okay? So as you can see here, we have a mapping, okay? We already described the most fundamental definition of a function is mapping of something to mapping of another thing, okay? Mapping of A to mapping of B, okay? So as you can see here, we are mapping the input to the output, okay? And the input is the preset sequence, okay? That is the things that the agent precedes, okay? And the things that is being mapped is the action. That is the agent is trying to do. You can consider this diagram as the graphical definition of the agent's behavior. Okay? 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 And you can also see that one preset mapped to one action. Okay, so for example, if the room that is at the left is clean, then of course the agent's action will go to the right to see if the right room needed to be cleaned. Okay, so using common sense, okay, we can deduce all these mappings. Okay, okay. And as you can see here, I've already talked about it, is that, for example, for the first mapping, the A clean means that the robot is at the room A, that is the left room, and the room is clean right now. So what is the action that the agent would do? Will of course move to the right. Okay? Okay? And I will not spend the time to discuss the rest, okay? Because it is very intuitive, okay? You can read at home, okay? And we can also extend our mapping to just from one precept to more than one precept, okay? So for example, we can also define the mapping of two precepts, okay? Two consecutive sensory input to two actions, okay? Okay, our agent function doesn't need to be limited to the mapping of one sensory input to one actions. You can actually have a sequence of sensory input mapped to a sequence of actions. Okay, okay, okay. You may ask is, Professor, so how the precept sequence or sensory input sequence mapped to sequence of action is really useful. Sometimes when you are solving problem that is sequentially associated to each other, then you will need to have this mapping. For example, when you are playing chess, you need to think about your opponent's move. You need to think about your own move. You need to think about beforehand several steps of the chessboard game. Okay. In other words, there will be a sequence of sensory inputs. Okay. So as a result, we will also have a sequence of actions. Okay. 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 And this is the graphical representation of sensory input to actions. Okay, it all looks nice, but we cannot enumerate. We cannot really we cannot really list out all the pairs, right? Listing out all the pairs of the sensory input to the action is very troublesome to do if you have more sensory inputs. Okay. The reason why it seems that it is possible because we are only working with two sensory variables in the environment. Okay, we are working with the location of the agent and the dirtiness of the room only. We only have two variables in our sensory inputs. Okay, so it seems that we can just enumerate all the possible, we can just list out all the possible sensory inputs and then list out all the corresponding output actions, and then we can call a day for defining the agent function. But in reality, if the environment is more complicated and it has far more sensory variable, then this approach of listing out all the or hard coding all the mapping will not be a good option. Okay, okay. Emergent listing out all the mappings like millions pairs into your codes. Okay, it is not that feasible. Okay, it is not scalable as well. Okay, 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 okay. I believe that every one of you, when you are writing program and you found that the program's output you cannot figure out how it's compute, you may have the strong desire to just hard code the input to the output and then to the program code and call it a day. Okay, but in reality, you know that that is not a good approach to solve problem, right? 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 So what you want to do is not to do the hard coding. Instead, you want to write a program. Okay? You want to write a program that map the sensory input to the actions. Okay? Okay. And as a result, okay, this is the thing we want to write. Okay, a function, a program, or a function implemented as a program. Okay, that allow us to map the sensory input to the actions or the preset to the actions. Okay, and all the AI we are working on is trying to implement this agent function. Okay, the agent function can be in any form. It can be in a neural network form. It can be in a decision tree form, or it can be ordinary coding of its standards. As long as it is a program that maps the preset to the actions, then we can consider it as the agent function. Okay? 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 No matter what kind of AI you're working on, what you are trying to do is to write an agent function like this that map the sensory input to the output that is the action. Okay? Okay? No matter you're working on neural network, no matter you're working on decision tree, or no matter you are writing a simple rule-based AI, just as the AI that drive the strategic games such as Age of Empires, okay? Those are all agent functions. They map the input to the output, okay? And as a result, okay, in the future, when you are describing the problem you are trying to work on to others, you should always talk about your input and talk about your outputs. Because that is the most crucial, most important two element that you should describe such that others can understand what kind of problem you are trying to work on. Okay? That is the reason why when you are listening to other people describing how the AI or what kind of problem they are solving, they will often talk about the input and the output of the problem. Okay? Because they are the most important things that you should talk about when you're working on a problem. Okay? So any questions? Any questions? Any questions? Any questions? Okay. And for the act, how the function really map to this mapping, graphical mapping, I will skip it. You can just read at home. You'll be able to understand very easy stuff. Okay. So the next thing we will want to talk about is rationality. Okay. Agent. What the agent does is to map the sensory input to the output. Okay. But knowing what kinds of input what map to what kinds of output is not the end of the story. Okay. Okay. When we are talking about the sensory inputs to and the outputs, okay, and actions, okay, we can have more than one choices of the action, and we can have more than one choices of the sensory input. So how exactly the what sensory action to be mapped to what action, such that the agent is performing its task the best is the next thing we need to discuss. Okay? All the discussion we done here is describing the nature of AI that is mapping the sensory input to the output action. Okay, but how essentially we define a mapping is good versus a mapping is bad is something that we haven't discussed yet. Okay, okay. So the next thing we need to discuss is rationality. Okay, we need to introduce a concept called rational agents. Okay, rational agents refer to an agent that do the right things. Okay, okay. You may ask is Professor, so how we define right things versus the wrong things? Okay, we define what is right and what is wrong. Very simple. Okay, we just define a performance measurement scheme, and then we test the AI against the scheme, and then we can define whether the agent is doing good or not. Okay. It may be too abstract to understand it. Okay, you just maybe you can consider as GPA, or maybe you are working in a company and you have a KPI to follow. Okay, okay. So we in the future when you're working in a company, so how your boss is evaluating your performance. Usually, the boss will have a list of KPI, and it will take the KPI and measure your performance against the KPI. Okay, if you satisfy all the KPI, then you will be considered a good employee. Okay, okay. Humans evaluate human in a company. Okay, humans evaluate other employees. Okay, your boss will evaluate other the employee using the KPI scheme, and we will use the similar technique in AI agent as well. So we will establish performance measurement and to measure the agent's performance. Okay. Okay. So when you are using when you are listening to the news of AI, okay, you may have heard something like false positive rate, false negative rate, accuracy, precision, F measures. Okay, all those are so-called performance measure. Okay, and the reason why we have so many different schemes is because different tasks have different ways of measuring the performance. Okay, okay. So for example, if you are working in Google, okay, if you are so lucky you get employed in Google, okay, the programmers working in Google and the marketing staff working in Google, they will of course have different KPI because they are working on different tasks. Okay, okay, okay. So the reason why nowadays you see the AI have so many different performance measurement criteria, such as the precision, the accuracy, the ROC curve, or all sorts of things. Okay, the reason why we have so many performance measurement is because when the AI is working on different tasks, there are different suitable performance measurement for a specific task. Okay, okay, and you cannot mix and match that. Okay, okay. For example, maybe okay, I'm just randomly saying, okay, I'm not exactly sure about how it's measured. Okay, so for example, okay, the marketing department of Google, okay, the KPI of the staff is how many business partner it can establish a connection with within a month. Okay, and the KPI of programmer is how many projects that the programmer can finish in a week, in a month. Okay, so these two KPIs are different because the post is different. Okay, you cannot measure the programmer performance by seeing how many business partner it is established during the work. Okay, because it doesn't match.
So it's about smartphone like relevant.
Yeah. The performance measurement should match with the nature of the task. Okay. Okay. So and the performance measurement will be objective. Okay, you cannot make some subjective measurement. Okay. Otherwise you cannot have a consistent reading on the performance of the agent. Okay. And it might be imposed by some authorities. For example, if you're working in a company, then your boss will be the one imposing the performance measurement. That is the KPI. Okay, and for the four cleaning agent, okay, the performance measurement will be, for example, the amount of dirt cleaned up within a time period, the amount of electricity it consumed, and how much free time the agent has to do to perform the task, something like this. Okay, so if, for example, okay, if you are deciding the agent for cleaning the floor, okay, you don't just want to measure whether the agent is cleaning the dirt completely clean. Okay, you don't just want to take a look on that measurement alone. Okay, because the robot is working autonomously without a wire. Okay, so it need to run on battery power, right? So if we created a cleaning box, okay, that have extremely strong suction and can clean part of the room extremely thoroughly, there is no dust left. But after cleaning that spot, then it run out of battery. It need to go back and recharge. Okay, then the overall time spent to clean the room will significantly be higher. Okay, than a book that is not so powerful and clean all the dust, but it conserves power more. And it have a better power in conserving power. Okay, so sometimes when you are measuring the performance measure of an agent, you don't just consider one criteria, you will also consider more than one criteria. Okay, okay. So any question up to now? Any questions? Any questions? Any questions? And in fact, in the future, when you are working in the field of AI, okay, you may have heard technical terms such as multi-objective optimization. And the objective is essentially talking about the performance measurement we are discussing right now. Okay? And I already discussed part of it is that when we are evaluating the agent performance, we need to consider the how when we need to discuss how frequent the measurement should be and how long the measurement of the performance should be. Okay, so for example, when your company is measuring your KPI, okay, the company can measure your KPI as frequent as one measurement per month, or 1 year, or one measurement per year, okay? Or 1 week, one measurement, okay? Okay. Let's consider you're working in a company, okay? And your boss is measuring your KPI, okay? The boss can measure your KPI every week, every month, and every year. Okay, so that will be actually the frequency of the performance measurement. Okay, okay, or we can also say how much sampling have been done on the performance measurement. Okay, okay, and when we are talking about performance measurement, we can also talk about how long the data is being collected. Okay, for example, when the company is measuring your KPI, each measurement can take 1 day, or each measurement can take 7 days. Okay, if you take longer times to measure the performance, then you get more data, but you will have a higher cost in collecting the performance data. Okay, so that is also the part of the consideration that you need to make when you're measuring the performance of the agents. Okay, and when we are talking about rationality, we are also talking about something that is reputable. Okay, if another agent have already achieved something, okay, and if that achievement is not by luck, okay, other agents should be able to recreate this achievement as well. Okay, so this is also a part of the rationality as well. Okay. So when we are talking about an agent is rational, okay, so we need to consider all these four things, okay. We first of all first of all need to we need to check whether the agent is following an objective, is being successful in fulfilling an objective, okay. And the second thing is that whether the agent can perceive the knowledge, okay. And then the agent need to know about the environment, and the agent also and what kinds of action that the agent can do. Okay. Let's say, okay, the agent is we have established a performance measurement on an agent, okay, but the agent has no knowledge, okay, to handle the objective, okay. Then you cannot say the agent is doing bad. Okay, okay. For example, we cannot expect anyone that is studying primary school right now, okay, any primary school student to be able to finish Hong Kong DSE exams, because the agent simply doesn't have the fact that is the secondary school knowledge. It doesn't have any knowledge about the environment, that is if the primary school student doesn't know anything about the HKDSE exam, and the primary school student doesn't have the physical development capable to solve the question shown in the HKDSE exams. Okay, so when we are talking about the agents is rational or not, we just cannot say the agent is performing good or bad against the objective. We also need to consider whether the agent is capable to fulfill this objective as well. Okay, okay. So for example, we cannot just push the HKDSE exam as a KPI on a primary school student and expect a primary school student to be able to finish the DSE exam. The primary school student doesn't have the secondary school knowledge. It doesn't know anything about the HKDSE exam format, and it also doesn't have the physical development, the mental training development necessary to finish that exam. If we push the DS exam to a primary school student and expect the primary school student to able to finish the exam, we are not being rational here. Okay, okay. So we cannot just divide objective measurement and shove and push it on the agent and expect the agent can just do that successfully. Okay, you also need to consider the fact and the knowledge that the agent know and the capacity that the agent has. Okay. And to summarize, okay, when we need to define a rational agent, we can define the rational agent as the following, okay? For every possible precept sequence, that is sensory input, okay? The rational agent should choose an action that is expected to maximize its performance measure given the evidence provided by the precept sequence and whatever building knowledge that it has, okay? That is, when we are talking about rational agent, we expect that rational agent can try its best to try its best in terms of the knowledge that it has, in terms of the facts it knows, and based on the capacity that it has, to try its best to achieve the given objective as much as possible. Okay, okay, okay. So as a result, we would not assume a rational agent to know everything. We would not expect the rational agent to can be able to predict the future, and we would also not expect the rational agent to be successful. Okay, but we expect the rational agent to be able to learn from its mistakes, to be able to explore the environment, and to able to autonomously choose the best possible action and try its best to achieve it. Okay, okay, okay.
Sorry, can you say, can you explain the exploration again?
So essentially, we are expecting the rational agent in ideal ways to be able to explore the problem and to able to solve the problem. Okay, so for example, when you are handling a problem involving search, we expect the agent to search for the best possible solution.
But
Okay,
isn't that about autonomy?
yeah, it is also part of the autonomy as well. Okay,
So they,
we can actually explain in the next slides. Okay, so when we are talking autonomy, okay, we are talking about the agent behavior based on its experience and real knowledge in an environment that it operates. Okay, so essentially we are talking about the agent's ability to operate on his own in the environment. But for the agent to operate on its own in the environment, it can done it based on its built-in knowledge. Okay, okay. For example, a simple organism can still react with the environment based on its reflexes, but in that sense, it is still interacting with the environment based on its built-in knowledge, right? So in that sense, you can say that this is rational. This is autonomous. Okay, but exploration means that the agent is in the environment, and then I try to get more knowledge about the environment and try to store this knowledge into the agent itself. Okay. Maybe so let's consider this. Okay. Let's consider this. Okay. I believe that every one of you knows this. Okay. When you have a hammer and you strike your knees, okay, your legs will kick, right? Okay. So there are some reflexes that is built into us. Okay, okay. And for some organisms in the wild, okay, they have those reflexes, and those reflexes can actually help those organisms to survive and to interact with the environment, right? And for an organism that have the built-in reflexes and to be able to interact with the environment built with simple reflexes, we already can consider that that organism is having autonomous actions. Okay, okay, because you can consider the reflexes is built-in knowledge. Okay, but if the agent can move around the environment and get knowledge about the environment and store it inside it, and the knowledge stored inside becomes the experience such that the agent can interact better with the environment using the experience, then we will call it as exploration. Okay, and we'll call it as the ability to learn.
so you mean it has its autonomy to go around the room, and
You can consider the exploration as a part of the autonomy. Okay.
exploration part of the,
Yeah. You can consider the agent being autonomous. Agent being autonomy doesn't necessarily mean it can explore, but an agent that can explore properly, it is autonomous.
so which one is the subset?
The exploration is being the subset.
Okay. Got it.
Okay. I've already actually covered these slides already. Okay, so essentially you can consider the agent action, the agent being try to explore the environment as try to learn about the environment. Okay, okay. So any question about this slide, or because I already covered these slides by making the discussion between exploration and autonomous. So any question about these slides? Any questions? Any questions?
So how about like learn, so you like, how about like the ability to learn? Is it a,
You can consider ability to learn as part of the exploration.
okay, so okay, ability to learn is the subset of exploration, right?
Yeah, you can consider
Okay,
something
okay,
like that.
okay.
So any questions? Any questions? Any questions? In fact, okay. In fact, in the future, okay. When you are trying to build AI systems, okay, you would not really it is seldom that you will go back to basic foundational definition like this, okay? But it is better that you still learn about the basic foundations, okay? In actual practice, okay, when you are building AI system, okay, you will try to create a system, okay, that will adjust itself based on given samples, okay? We'll call this behavior as learning. Okay, okay. And you can consider exploration as we give data sets to the model and let the model adjust parameters. Okay, okay. If we really need to go back to the actual implementation, it will be something like this. Okay. So any questions? Here we are just laying out all the definitions only. Okay. So in real practice, okay, we will not really build a AI that really acts as an organism in the world. Okay, we are just trying to lay down some basic definitions only. Okay. So when we are designing a rational agent, okay, we will need to define the problem for the agent. Okay, we will need to describe exactly what kind of agent we are trying to do. Okay, and when we are defining a rational agent, we will need to describe the performance, the environment, the actuators, and the sensors. Okay, so essentially we are defining, okay, the 4 elements that we have here. Okay, the performance, the actuators, the preset, and the environment. Okay, so when we are deciding a rational agent, we need to define all these 4 things. Okay, so for example, let's consider the autonomous driving agent as example. Nowadays, I believe that you know that we can design a AI that can drive a car, right? Yeah, something like this. Okay, and for the AI car, okay, to drive around, okay, it needs to interact with the environment. We need to also know what kinds of action that the car can do, and also what kinds of sensory input that the AI car can have. Okay, so we will need to describe the performance, the environment, the actuators, and the sensors. Okay. And first of all, for the performance, if we are trying to describe how an AI driving algorithm for the car would work, okay, when we are talking about performance, we can consider the following facts, okay. So let's recall the news about AI autonomous driving. Okay, we have different levels of AI driving, right? Okay, and the different level of AI driving is actually tied to whether the AI is able to handle sudden and accident situations. Okay, so and also we will also check whether the AI is conforming to the law regulations while it is plotting a driving path to a destination. Okay, so as a result for the performance, we will have safe and legal. Okay, the AI driving agent should keep the driving to be safe. Okay, safe for the car itself and safe for the people who is in the car as well. And it needs to be legal as well. Okay, you not want the AI break the laws. Okay, and meanwhile, you will also want the AI to be fast and comfortable trip. Okay, if the AI driving is safe and legal, but it gets to the destination very, very slow, okay, that is something that you probably don't want. Okay, so you also want the AI agent to be able to go from one starting point to the destination extremely quickly as soon as possible. Okay, without compromising on safety and legal aspects. Okay, and you also want the customer and you also want the people sitting in the car to be comfortable as well. Okay, and the last point is that because nowadays the AI driving car is deployed on electric car, and electric car have limited battery power. So you also want to minimize the energy usage as well. Okay? Okay. So as you can see here, when we are designing an AI agent, we are not just focusing on one performance measurement. We can have multiple performance measurement. Okay. And actually, this is something you must understand. Okay. Normally speaking, you would expect that when I am designing AI, okay, I just need my AI to perform the best under one performance measurement. Okay, but in fact, in many situations, we want the AI performing not just good in one situation, and we want the AI to be performing good in multiple scenarios, multiple measurements. Okay, judging from the AI car example here, we can establish the fact that our AI agent should be able to perform good in more than one dimensions. Okay. Okay. And that is the reason why when you are reading state-of-the-art research paper, you will see this term that is called multi-objective something a lot. Okay. Because in reality, when we are designing AI, the AI should be able to do a compromise and try to establish as many performance measurement as possible. Okay? Okay. So any questions? Any questions? Any questions? And when we are talking about environment, when we're talking about autonomous driving, of course, the environment can be roads, can be other cars, can be police, can be pedestrians, can be the people who is sitting in the car, and can be the weather conditions. Okay. So, for example, if there is raining conditions, okay, then the car need to have a more strict controls on its braking, okay, such that it doesn't such that it actually allocate more flexibility while it's braking and to avoid any collision with other cars. When you are in a raining condition, then the friction between the tires of the car and the road will get lower. Okay, so for a car to start braking and stop when the car is driving, from stop when the car is trying to stop, okay, the distance for the car to stop will be longer in rainy conditions. So the AI, when the AI sense that it is raining, then the AI need to adjust itself such that it actually left more distance from the car in front of it, such that when the car wants to stop, it can stop before the collision occurs. Okay? Okay. And for example, if suddenly in the road there is a pedestrian, then the AI need to automatically stop and prevent collision. Okay. So these are the environment that the AI agent must need to handle. Okay. And the third is the actuator. Okay. The car can have the steering. Okay, that is turning the direction of the car by turning the front wheel. Okay. And it also has the accelerator brakes, okay, such that you can increase the speed and decrease the speed of the car. And it also has the signal horns, okay, such that it can notify other road users. For example, if there is a sudden pedestrian crossing the road, then the car can automatically use the signal horn to warn the pedestrians, okay, something like that. Okay, and finally, there is display and speech. Okay, so for example, the AI agent need to interact with the people that is sitting inside the car, then it will use the display and the screen to do the interactions. Okay, okay. And finally, when we are talking about sensors, okay, for example, different car brands will use different different sensors to sense the environment. Okay? For example, Tesla is just using cameras. And some car company will combine the camera and also radar signals and laser radars, okay, to to generate multi-modal data, okay, such that it can sense the environment better, okay? So it depends on what kinds of sensory input you have. Then your AI will have different design as well. Okay, so the Tesla solution for sensing the environment is different from other car companies because the Tesla is using only cameras and other company is using camera and also laser radar. Okay, that's called a LiDAR. Okay, so for other car company, their model will of course the AI model will of course be different from the Tesla ones. Okay. So as you can see here, the sensors, the sensors, the actuators, okay, the environment and also the performance will actually affect how the AI model, how the AI agent would be designed. Okay, okay. So for a recap, okay, for example, when you're designing AI driving agent, you want the AI driving agent to strike a balance between all these performance measurement. You also want the AI agent to handle all these sudden environmental changes such that the AI agent can adjust to the environment. And you also want the AI agent to adjust to the environment using all these actuators, right? Or I would say, if we do not define what kinds of actuators, what kinds of means that the AI can interact with the environment, then we cannot define how the AI should respond to the environment. Okay. So, for example, if your car doesn't have a display, then your AI would rely solely on speech to interact with the people sitting in the car. I'm saying the extreme situation, but that's how it works. Okay, what kinds of actuators they will have would actually affect how your agent will interact with the environment. Okay, if your car doesn't have a speaker inside the car, then the agent will rely heavily on the screen to interact with the people sitting in the car. Okay, so the actuators will also affect your AI agent design as well. Okay, and finally, for the sensory input, okay, what kinds of sensory input you have will also affect how you design the AI agent as well. Definitely, Tesla and other car companies will have different different approach in designing the AI agent because Tesla is just using camera vision as the main sensory input, and other car company is using radar plus camera, these two different kinds of sensory input to create the AI agent. So for other car company, they will need to align the data collected from two substantially different sensory input and make the AI do the decision based on all the sensory inputs. Okay? Okay? So any questions? Any questions? Any questions? Any questions? Any questions? So maybe you can also consider it in this angle, right? So for example, if the camera is capturing what is happening in the environment in 60 Hz per second, for example, okay, 60 Hz, okay, 60 Hz, okay, that is the camera will take 60 frames of the environment each second, okay, but the radar will try to scan the environment twice per second, okay. Then now you have two different sensory input with two different frequencies, okay. Then how you merge the signals with different frequencies together will be a major challenge. For the AI agent, they have multiple sensory inputs, okay? If you only have one camera, then that issue is not a problem for you, okay? So that is why we'll say the sensors, the environment, the actuators, and also the performance will affect how you develop the AI. Okay? Okay? For example, if you only have one performance, then it's very simple. You just make sure you get the highest score for that performance measurement. But if I have more than one performance measurement, then I may need to rank which performance measurement is having a higher priority over the other performance measurement. Okay. And if you prioritize safety and legal first, then your agent will have different behavior compared to the AI agent that prioritize fast first. Okay. So if when you have more than one performance measurement, then which one to be prioritized will affect your AI design as well. Okay. Okay. So any questions? Okay. So the next thing that we need to discuss is environment. Okay. When we are trying to describe the environment to others, we actually have a set of terminology we should use. Okay. And now we'll discuss those terminology one by one. Okay. First of all, we have fully observable vs partially observable environment. Okay. If the agent can have full access to all the elements that it need to know when it is making decisions, that is called fully observable. Maybe I will jump into the example directly, okay? So for example, when we are talking about whether the agent is having an observable environment, if the agent is able to fully observe all the technical details it needs to know from the environment to make the decision, then we will say the environment is fully observable. If the agent is not able to fully observe the environment before making its decisions, then we'll say the environment is partially observable. Okay? So, for example, let's consider playing chess, okay? When you are playing chess, okay, you can see all the chess pieces location of your opponent, and you can see all the chess pieces location of yourself. So chess is having a fully observable environment. Okay? Okay? On the other hand, if you are playing poker will be not a partially observable environment. Okay? So if you do not know what poker is, okay, you can recall the movies in the 1990s. Okay? Okay? In the 1990s, okay, there is a bunch of movie about gambling, okay? With the main actor featuring Zhao Xingqi and Zhao Yunfan, okay? That is called God of Gambling or I don't know how to translate English, but you get the story, okay? But I guess every student here get what kind of movie I say, okay? So unless you are being the actor, unless you are being the character acted by Stephen Chow, okay, you supposedly do not have the ESP power to look through the card, right? So you only see your own card, but you cannot see your opponent's cards. Okay? In the poker game illustrated by those gambling movie, okay? Zhao Xingqi, okay, Stephen Chow is the character portrayed by him, okay, is so powerful. He can use ESP power or in Chinese 特異功能, okay, to X-ray, have some sort of X-ray vision to look through the card held by other opponent, right? Right? In that sense, if you can do it, then poker game is a fully observable environment for you, because you can see all the cards that your opponent is having. But in real situations, in real world, we don't have X-ray vision. We cannot see the opponent's card, so we can only see our cards. So that is why we'll say poker is a partially observable environment. I can only see my own cards. I am doing the decision based on partial information. Okay. If, for example, if I know that, okay, the the deck in the middle is going to give me the card I need to construct a straight flush. Okay, then my decision will be completely different, right? But I don't have X variation. So when I am doing the decision whether I need to acquire extra card, it's based on guessing. Okay, and I'm doing the decision whether I should get extra card based on the guessing of what my opponent is having. Okay, so that is why we call it as a partially observable environment. I don't have full information to make the best decision. Some information is missing, and I need to do guessing. Okay, okay. So if you don't understand what I'm saying, just recall the gambling movie. Okay, then you get the idea. Okay, if you are the character portrayed by Stephen Chow, okay, then you are playing the fully observable version of gamble of poker. Otherwise, it is the partially observable version of game of poker. Okay. So deterministic. Okay. So if when you are making the decision, okay, so for the deterministics, okay, if the next state of the environment is completely determined by the current situation, then we'll call it as deterministics. Otherwise, it is not deterministics. Okay, so let's get back the poker game that we are talking about. Okay. I believe that most of you here should at least watch those movies. So in those movies, you may not know how poker really works, okay? But you should know that the card you get next time is random. Okay? You can only decide whether you get an extra card or not. But what card you can get is not something you can determine. Okay? Again, if you have ESP power, you can use your hands to touch the card very quickly to change what kind of card that you are having, then that's another story. Okay, but in real world where there is no ESP power, then you cannot just suddenly rub your card so frequently that the card is changing what card is, right? So when in a poker game, your decision is get a card, but you cannot decide, you cannot control what card you get at the end. Okay, so that is called stochastic. Okay, so for example, also I choose another example that I think you have a better experience with. Okay, so I guess every one of you here play board game, right? Okay, for example, Dungeons and Dragons. Okay, you can choose the action you can order your character to kill another character. Okay, but that action, whether it is successful or not, you need to roll the dice, right? So you can choose to or order your character to do something, but the outcome is not determined by you, it's determined by the dice. So your outcome of your action is not something you can totally control.
Sorry, excuse me. What does the ST?
So stochastic means
No, straight is STRAT, like with the stuff.
Oh, that is called strategic. Okay, strategic means when you make a move. Okay, you cannot know when you're making a move, you can be quite sure what will occur except your opponent. When you're playing chess, okay, when you're playing chess, okay, when you make a move, okay, you will know what is your chess pieces will go to. But the only thing you don't know is what is your opponent's action. Okay? Okay? Okay?
So deterministic means is it about the result?
Yeah, your result. So when I'm making a move, okay, I will also need to see my opponent's response to my move. But other than seeing the opponent's move okay, all the things can be known. I just don't know what action that my opponent will make. And to be honest, I can kind of guess what my opponent will take as well. Okay? In that sense, I will call it strategic. Because in a chess game, okay, when I'm making a move, okay, the opponent's possible action is something I can totally compute.
So you mean as long as it's something that's subjected to a thing that is not totally random, that is Cartesian.
Yes, you can. You want to simplify? Yes, you can consider something like this.
You somehow know, but you don't. You're not okay. Maybe A, B, C. You know,
Yeah.
one of the options.
Yeah.
That's it.
Yeah. For episophic. Episophic means whether the things are connected to each other. Okay. So if it is episophic, then each event is not connected to each other. If the thing is not episodic, then it means that it's sequentially done, and each step will affect the other events. Okay, so for example, consider the soap opera that we have. For example, like Eureka. Okay. For example, in some rom-com, okay. For example, in some I would say for example, in some sitcom, okay, soap opera, okay, soap opera, okay. Each individual episodes is not tightly connected to each other. Okay, for example, like Big Bang Theory. Okay. Or Friends, okay, this kind of TV drama, okay. Each episodes are not tied to each other. Each episode stand alone, and the audience doesn't need to know previous episodes in order to get the main idea of that episodes, right?
So is it an example of non-episodic?
It is the example of episodic. Episodic means the things are disconnected to each other.
But they are not totally independent, are they?
In the ideal situation, okay, if you are in an episodic task environment, each sequence, each sensory input to output should be disjointed from the others. So each action is independent from the other. But in reality, we seldom have these situations, okay? So for example, when you are going to the doctor, okay, when you are going to the doctor to see the doctor, okay, if we are talking about the most simple situation, if you are talking about just going to the doctor for a common cold, okay, then your common cold this time should be independent from the common cold you have in the previous time. Okay, then that should be called as a solvent. Okay. 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 So any questions? Any questions? Any questions? But if you are having long-term illness, and if you are going to see a doctor for a long time, then each visit will be connected to each other. Okay, your doctor when he or she sees you, then he will refer you to your previous medical record, and then it will evaluate your current situation based on your previous medical history. Then in that situation, it becomes sequential. Okay. Okay. So this is the difference between sequential and episodic. When you are working in an episodic environment, each sequence is each sensory input is mapped to an output. But this mapping, it will not be related to the next mapping. Okay. Okay. So any questions? Any questions? Any questions? And also in computer science or data science, when we are talking about something that is occurring independent from other things, we'll use the term atomic. Okay, we'll use the term atomic. Okay, the term of atomic will appear again when you're working in database. When you are learning database, you will also learn about transition. And when you want to say a operation is independent from all other operations, you will also use the term atomic. Okay, so you should take a look on the term atomic because this will be useful later in other courses as well. Okay, so here we use the term atomic to specify a event, okay, or a sensory input to action mapping is independent from another moment's sensory input to output mapping.
So do you mean, yeah, in the context of data science, independent and atomic are interchangeable, like totally interchangeable?
I would not say it's totally interchangeable because it depends on the usage of the context, okay? But you is similar, okay? So I will talk about static versus dynamic, and also I will talk about discrete and continuous next time. Okay, so I think I will because now it is 2:21 again, and our class supposed to end at 2:30. So I think that now is a good time for us to stop. Okay, and I will also end the Zoom recording as well. Okay, this